I think so.
All right, so Andy already gave a definition of a dictionary. We use key value pairs. If we put in dog, we get has a tail and goes woof. Now, this is not how you normally use a dictionary by having to type in the key, but it is a good demonstration of how it works. And actually, I called this dictionary. Oh, that's kind of a weird name. Anyway, it doesn't fight with any libraries or anything because this is built into the Python, what's called a standard library. Every programming language has a standard library of stuff that it has built in that you don't have to add. For instance, in Python, if we want to do random stuff, we have to import it. And that's not part of the standard library. All right, so now we run this puppy. And it gives you the hint here. If we type in dog, it returns key dog value has a tail and goes woof. So, and normally you do not type in the word. Why do we use get? Because you'll see dictionaries use this. It'll use brackets. Why do we use get? Either of you remember?
It's looking for that.
You're trying to get the,
It's safer. If you do .get, it returns the value if the key's in the dictionary. Otherwise, default means it returns nothing. It doesn't give an error.
Oh, yeah, and then if there isn't something there and you do it with the brackets, it could return a memory space.
It would give you an exception.
Oh,
So I almost always use .get because it's safe. It doesn't crash your program, and that's what this week is about, is safe programming. I don't do all my safe programming here in this chapter, but safe programming means you use as much as possible to make sure that the input is clean. You want clean input. And any method that you use, if there's a safer way to use it, well, it's safer to do .get because it doesn't cause an exception. It handles it automatically. So if I point at it, it says return the value for the key if the key is in the dictionary. Otherwise, default means it just doesn't do anything because it doesn't exist. And this is where you put the default value. So it's like having a try except. Normally the bracket would generate an exception. You do not want unhandled exceptions in code. And a large part of cybersecurity is becoming secure code. So many cybersecurity degrees are including computer science and math and all kinds of stuff now. So this is the default value if it doesn't exist. So for example, if I put in the wrong input,
giraffe.
it doesn't blow up. If I had the bracket, it would blow up, and you don't want things blowing up because hackers can take advantage of that and then write information to memory spaces that you don't want them doing things to. So secure coding is about making sure you have clean input, that it doesn't generate exceptions. So far, so good. So this one, I hadn't thought about it till today as I was kind of glancing at the chapter, that as much as possible, you want to try to find some way to make sure there's no exceptions generated. While you're developing, that's fine, because exceptions show you where your code isn't working right. But once you have production code, you don't want exceptions that you don't handle as much as possible. All right, so what's the next one here? Product price dictionary. Product price dictionary, product price dictionary. This is number 2, apparently. All right, so we've created an empty dictionary. Before we created a dictionary and put stuff in it. Well, we're going to do input. Right now, there is no dot set that I'm aware of. There might be, but how would you generate an exception where a dictionary can handle any type of variable? So there's really not something you can type in here that's going to cause a problem. We've already said it has to be converted to a float. Oh, but what aren't we handling here? Are we handling all exceptions in this program while we're talking about exceptions? Jessica, Andy, are we handling all our exceptions? Is this safe code?
No,
No. What am I not handling?
empty one.
And empty would actually be a null string, which would be fine.
Okay,
What would happen if I typed in a string when I'm expecting a float?
blow up.
It'd blow up, so I'm not handling that. And with safe code, you want to handle as many exceptions and input validation as you can, so you don't allow input that doesn't belong there. So I could, as far as I can tell by looking in this, that's the only place that we'd have trouble. So you can write test suites and stuff, and we're not going to get that far. But my product is, well, I can put in numbers here. I could put an enter key, but a blank key, how do you retrieve a blank key? Because when you press the enter key, all you're putting in is the enter mark, which means you're putting in an empty string or a null string might be. But if I put in the wrong stuff here, uh-oh. And it tells you what's going on. It could not convert a string to a float. Well, is that a string? Yeah, it's a string. But it's expecting a number. So how we would handle that, I don't remember if we've done that before. All programming languages have a try of some sort, which means we're going to try, if we generate an exception, I think it's as e. That's not right. What is it, Mike?
Exception.
Exception e.
Mhm.
There we go. No, that's not right either. Oh, I misspelled exception.
Try and accept exception.
Oh, yeah, capital exception, exception.
Accept exception with capital E. It's a universal.
No, the
EX.
Capital E.
Yeah, try accept exception.
Oh, yeah, you're right, because we're dealing with a class. Exception is the general class for exceptions, and we won't go to add the other part because I can't remember how to do that. So this means any exception, we don't care what it is.
Isn't it
Except
exception?
the word except before
Before exception.
exception, yeah.
Oh, brother. I told you I wasn't feeling good.
Yeah,
Except and then
except and
exception.
an exception.
Exception?
Yep.
Yeah,
Oh, exception as
Yes.
as E, so we can then see the exception.
Yeah.
All right, good grief. All right, so please try again, or something is what you'd say.
Or Romaine or something.
Yeah, and so the exception is handled. What else could we do here to handle this? So it goes back to the beginning. What do you think, Andy, Jess? How can we go back to the beginning in this while loop and not go any further and make the user put in the right stuff? Because this is good
Continue.
exception handling. Yeah, exactly. Now we have fairly bulletproof code. If there is an exception of any kind, you can catch specific exceptions. But if you just catch any kind of exception, that's better than not catching any exception at all. So far, so good. So we made this a lot safer now. So if I try to type in something dumb, put bill as the product name, enter the price. Yeah, see, I'm zipped back. And I have to enter it again. I should say, put in a number next time, dummy, but I didn't. So we're going to sell bats. And our bats are very expensive. They are $100 a piece because they're custom bats.
And that is some expensive bats.
Yeah, well, they're custom. I make them out of, I spend 8 weeks making a bat, so I want to get a lot of money out of it. So we're in a while loop, right? So there's nothing else I can do to break this program. If I do Control C, I can break the program because I'm not handling the keyboard interrupt. But we're not going to worry about that today. So there are specific exceptions where you can handle the keyboard interrupt and then make sure that even if they do Control C, it doesn't break the program. That's more than what's in the tutorial, but that's what we want to be here for, is learning these things. Now, we can, because a dictionary can hold any number of different types of data, this is fine. There's not a special dot set like there is a dot get. So we're setting the product price, right? And we're setting it to the product name key. So whenever something's over here, it gets assigned to that. And the other one we looked at, we were getting it. Right, we're getting the information from the key and returning the value. So the value is on the left-hand side. So everything in programming languages works from the right to the left. And we're just printing it directly, which is ugly. However, we can print it with, I call it a for each loop. Because that's what it's called in other languages. Python doesn't call it that. It's a good way to understand what the loop does. So for each key and value in the product dictionary, items means each pair of values maybe would be what you might think of it like. So the dictionary has a bat and a price. So that's one item. If I also had a glove for $500, that would also be an item. So each key value pair is considered an item. And this allows us to go through for each key and value in each item. That's why I call it the for each loop, even though Python doesn't call it that. It's an easy way to explain how it works. So when you get to the end of the dictionary, what happens?
It's over.
It's over. It's done. You don't have to have an index or anything. It's pretty safe. It's built into Python. You go through, oh, we're at the end. That's it. We quit. And we move on. Exactly. And this gives a much nicer look to it. And looking pretty is part of the game. So I'm going to put in my glove. This is, by the way, a Michael Jackson type glove. So we're going to charge $500 for it. And I'm going to press enter to, yeah, which one do you like? This one or this one? We can do whatever we want with that. This is just the raw dictionary information. Let's enter another item, see how it stores more than one dictionary. So another item. What shall we sell? A car. Let's sell it for, I don't know what cars are right now, but they're pretty expensive. There. So this is a set. Or you can think it's an item. Sorry, that's what it's referred to in the dictionary parlance or the dictionary terms. These go together, these go together. So for each key, we get the value. For each key value, we can return that. Then we go to the next one. When it reaches the end, it says, okay, we're done. And then it takes off, it finishes. Pretty safe code. And now we press enter to exit. So how did I do the press enter to exit? Look at here. And we're talking about empty strings, or I don't know if that's an empty string or a null string. I think it's just an empty string. Or it has the enter mark in it, probably. No, the enter mark pushes it. Yeah, I don't know.
Yeah.
Anyway, it's an empty string. If I press the enter key, that's the string I get. So if you want to have enter to exit at the end of your program, have choice equal to a blank string or an empty string. Because that's what the enter key gives it. It gives us no input at all. How about that? Does that make sense, Sean?
Mhm.
If I can keep you up with it, I should be good. Now, this is great, but what if we want to come back the next day and retrieve things? Well, there's a handy little thing in Python called pickle, which I think is an interesting name. I've always thought it was called pickle, and I've never looked it up because you're preserving it, right? You're preserving the information for the next day. So where's my pickling? There it is. So any object in Python can be pickled. An object can contain all kinds of stuff in it. We are only doing a dictionary, but you could pickle any object, which can contain lots and lots of dictionaries and lists and all sorts of things. So we are, yes, creating an empty dictionary. This one is we're reading that file. Why am I not saving it first? I don't know, I must already have a dictionary, right? Oh, here's my list. Oh, there's why my program starts. No, my program starts right here. You know what happens when you write things. Even if you comment it, you can't remember what the heck's going
The
on.
file, it was in the beginning, pickle. I saw this. This is file name, yeah.
Although I must have, okay, anyway,
Oh,
regardless.
there's file name used.
Yep, there's my file name. PKL is just a convention. I've seen other extensions to it. I just use PKL. I think I've seen pickle, the word pickle in there. So with open, so we're catching our exceptions. With open means we are going to open this file up. We get a file handle because we're talking to the operating system with Python. The operating system does our file access for us. We don't have to write all the code to open a file. Because if we put this on Linux, it has a whole different way of opening up files. If we put it on Mac, it has its own way. But Python talks to the operating system. Anytime you're accessing outside resources with a programming language, you are telling the operating system, hey, I want to get a file handle. And the operating system takes care of it for you. And we're going to read this, and you can do pickles with binary or text. I just always do them as binary. And binary is not like you can't open it up and just read it directly, like you could a text pickle. A text pickle, that's funny. Okay, so we're going to open load, is what they call it in pickling. They load, which would be like opening. We're opening that file handle. And when we open the file handle, all the information stored in that file is read into memory. Because a pickle file is a long-term storage file. It only exists on the hard drive. You can't look at the file until you open it. It's in storage. When it's in long-term storage, you can't see anything. So we open it up, we load it in this dictionary, then we can see it. And then we do the same thing we did before, product price and our items. And if the dictionary is empty to begin with, it's gonna just basically create a file. And if something goes wrong, well, except I have nothing doing with the except, I'm just saying pass, let's just keep going. Do I have a pickle in here? Yeah, let's delete that. That'll be from the last time I ran this. Then we go into our loop. Well, we're going to build up our dictionary, right? We just did this. We're going to insert it into the product dictionary. Each time around, we're going to write to the file. And then we enter another item and we're going to write to the file. So there's two different ways to write to a file. Write means we're doing the whole thing from scratch again. Append, if we used append, we'd be adding on to it. But we're putting our dictionary into I thought we were putting our dictionary into a list. Write list to file. Oh, we're adding it onto the dictionary, so it's not, we're not writing the list, because as we add things to the dictionary, we have everything already in it. I don't know why I have list in there. We're going to write the dictionary to a file, because every time we add something to it, our dictionary gets one more thing. All right, let's try it out. Here we go. Product name. What should we sell this time? A boat. Oh, a boar. Okay, we'll say it's $12. All right, so we dumped it. Well, we'll enter another item. We'll do steak. And this is expensive steak. There. So we entered exit. Well, we have no idea if we actually did anything or not at this point, did we? So the next project should be, let's read this puppy in and see what's in there, right? Oh, why don't we read it in? Am I reading it? Oh, I'm reading it as
In the beginning.
yeah, I read it in at the beginning. So if I run it again, I should write a different one where we just, yep, see, there's my dictionary. I could put in a little menu where I can open it up in the middle of the program, but there's my dictionary. It's loaded in the pickle file. I tried to keep it halfway simple, but you could expand from here and store whatever you wanted. Now the assignment is to create a sports team roster. Ooh. Well, let's look at that. I give you an example team roster. You can do whatever you want. We're not gonna, you can put enter in it if you want to. We're not gonna worry about that. You don't have to have input. You can if you want. We already know how to display the team roster. We know how to add a team player, but how do you update a position? If I want to update a position, I would print it out. Let me find it here. Did I do that one? Sometimes I don't do all these things. Okay. So
We need a list for positions.
So I updated Alex's position to forward. How I do that is I do the dictionary name bracket Alex equals the new position. So I'm assigning the position to an existing dictionary entry. instead of creating one, like what we did before. Here it is. No, that's in the way. And where is it? Where we put stuff in? The empty dictionary. There we go. So if I put product price in with a product name, I'm good, right? Now, if I want to update, for instance, my boar price got really high because there's, the boars are all dying off from a boar flu or something. If I do this, what do you think is going to happen? You can only have one key at a time, so they have to be unique. So if I enter boar and type in 200, it's now 200 because the keys all have to be unique. If they aren't unique, then how do we know who is what? It's like in this room, everybody's name is unique. And if there were 2 Bills or 2 Jessicas, I'd have to say Jessica 1 and Jessica 2, right? Have to have some way to distinguish.
Or more like Jessica A and Jessica B.
It could be, but I'm thinking of thing 1 and thing 2, from Dr. Seuss.
I usually just use the first initial of the last name.
Yep, that would work. Anyway, how do you remove a player by the name? Well, you may have to look that up. That's just a shame I don't give you everything, isn't it? But there is a function with dictionaries where you can remove a key and a value. What else do we do in this thing? Check if the player's on the team.
Well, what if you want to keep the key the same, but you want to change the value?
I just did that.
Oh. Oh, yeah, you did.
Yeah.
Well, if you want to do that with a database.
With a database, you would do the same thing. You bring up the record and update the value. There's update SQL for that. Check if a player exists. Well, it's the keyword in. So there's 2 things you have to look up, which is fine. I don't like to give all the answers. Preguntas?
No.